Hey everyone, Geophysicist Stefan Burns here. Over the past couple of years, we have seen major earthquakes along the Ring of Fire, indicating that the Pacific Plate, Earth's largest tectonic plate, has been actively moving, but most of those earthquakes have been concentrated in the Western Pacific. So think Japan, think Taiwan, think Indonesia, the Philippines. We have yet to experience major movement in certain key locations like California, the southern part of South America, New Zealand, Papua New Guinea. These areas are overdue for magnitude 7+ earthquakes, and that is looking increasingly likely as we go forward in time because we are going from solar maximum to solar minimum. We're right now at the end of solar maximum for solar cycle 25, the beginning of the descending phase where sunspot numbers go down, solar activity goes down, and in general, geomagnetic activity from these solar storm impacts decreases, though right now, as I record this on the 27th of May, we do have sunspot numbers increasing, and we do have a critical planetary alignment coming up on the 1st of June, so we could be getting some solar activity around then. And we are having earthquake activity over the past week increase. We just had 2 magnitude 6 earthquakes strike south of Australia along the plate boundary between Australia and Antarctica. We recently had the magnitude 6.6 earthquake on a mid-ocean ridge. We also had the magnitude 6.9 that struck South America, Chile. We've had increasing activity out of sync with the coronal hole cycle that we've been tracking. So we're starting to see this increased earthquake activity manifest as a result of solar activity going down. But there is this paradox where at times solar activity is also increasing as earthquake activity is increasing. And this solar cycle really has been defined by that because we had the strongest earthquake in a long time, going back to 2011, in July of 2025. That was the magnitude 8.8 megaquake, Kamchatka. So right over here. And that occurred during solar maximum. So perhaps that's a key indication that we could maybe expect even bigger activity in the years ahead. That is certainly possible. And considering the fact that if we look at the longer rhythms of solar activity, known as Gleissberg cycles, these are about 85 to 100 year long rhythms in solar activity, we are near the bottom of a Gleissberg cycle, meaning more earthquakes. And that has certainly been the case for the 21st century. You have the magnitude 9 Sumatra quake, December 2004, the magnitude 9.1 that struck Japan, March 2011, and the magnitude 8.8 that struck Russia, Kamchatka, in July of 2025. And so in today's video, we're going to examine the recent activity along the Ring of Fire and for the Pacific Plate because this is the biggest tectonic plate on the globe that has been making the biggest moves, and there are certain key areas that have yet to experience significant ruptures, indicating that they're likely to be the next locations to have significant earthquakes. And as solar activity in general continues to decline, we're very likely to see more and more global earthquake activity. So with that, let's jump right into it. So let's begin with our recent earthquake and solar activity, and then we'll look at the longer term trends to forecast out not just months, but a few years going forward. So here we have our USGS latest earthquakes map for the past day. If I set this to largest magnitude, you notice a double burst that occurred right here south of Tasmania, here along the boundary between the Australian and Antarctic plate. So this is a 6.0 and a 6.0 occurring within 9 minutes of each other. So boom, boom, double burst, magnitude 6 earthquakes on these sort of spreading centers is a bit anomalous, but we do see them. We'll see an example, a whole bunch of those with our map that we're going to look at for the past 3 years or so in just a moment. But these are both transform strike slip earthquakes. So these are not earthquakes exactly along the mid-ocean ridge. They are along a transform boundary. And this is just showing that there is some movement in general between the Australian plate and the Antarctic plate. Now this is coming as we have sunspot numbers on the rise. So here we have our estimated sunspot number for May, and we see that the average is about 100. And this is a bit more than it's been for April and March, which were both around 80 or so. So our sunspot number on average for May is higher. It's likely to continue to stay at these high levels going to June. We see that right now it's well over 150. We're at about 180 or so, maybe like 177 right there. So our sunspot numbers are going up very clearly. If we look at our proton flux, we know that we had this big explosion on the far side of the sun just a couple days ago that triggered an S1 proton radiation storm. We see that clearly right here. Normal values for proton flux is about 0.2 or less. So this is particles per square centimeter per second, okay? And well, to get to this warning threshold, you need to go over 10, and in fact, our greater than 10 mega electron volt protons went up to more than 22. So a huge increase, 100x increase in our lowest proton flux rating for this scale here, which is greater than 10 mega electron volts. And that's still actually very, very energetic. You could measure them in kilo electron volts and more. You notice that our other ones did budge as well. They went up, our greater than 50, greater than 100, showing that was a big explosion. Our greater than 500 mega electron volts did not budge at all. And that's a good thing, because to see that line go up means that this is really quite a serious situation, especially if it's Earth facing. This was on the far side of the sun, and we still got this radiation blast. And there is a connection between radiation storms and stronger earthquakes. So keep that in mind. That research is out there. I'll link that in the video description. We can see these sunspots right here on the sun. So they've been fairly inactive overall, but we have this big one rotating into view, as you can see right here. This is a sunspot that did blast off some big activity on the far side just a few days ago, a week ago. So that's a big core, and usually you need complexity and mixing and all this stuff to get a big solar flare, explosion, coronal mass ejection. Not always. So the fact that we have this big core rotating into view will be Earth-centered direct in about 6 to 7 days means that we just in general have a higher risk. Of course, these guys need to rotate through Earth-centered direct. These guys are already there right now, but this is definitely something to watch. If we look at our X-ray flux for the past month or so, you see that we have been a little bit lower back in April. In fact, it's on the 20th of April that we had that magnitude 7.5 that struck Japan. You see that X-ray flux was quite low in the B-class zone. Then we had this huge surge of activity right afterwards. You see that we are still holding slightly above that, but in general, our X-ray flux is at this low C-class, high B-class zones. If we're talking about longer rhythms, that 11-year solar cycle rhythm, it's when there's less X-ray flux and therefore ionospheric charging that we get these big earthquakes. But the ionosphere being charged up is an important component of this. And this sort of proton storm charges up the ionosphere. These sort of solar flares and sunspots in general, when you have sunspots on the sun, they emit more EUV, that's extreme ultraviolet, and X-ray light. They charge up the ionosphere. And then it's almost once that charging influence goes away that you get these big earthquakes. So this sunspot right there in particular, again, it's going to be Earth-centered direct in about 6 to 7 days. Well, if we look at our planetary geometry for the 1st of June, so right here we see this is June 1st, 2026. This is heliocentric true sky. So we're looking at the constellations, not signs. This is not a geocentric chart where Earth is in the center. This is a heliocentric chart. These are the conditions, the characteristics you want to use for space weather forecasting if you're using planetary geometry. We notice some pretty significant planetary geometry. We have this basket here. This is very clear. So you have this trine between Pluto and Uranus, which is conjunct Ceres at this moment in time. You also notice this trine between Neptune and Saturn down to Jupiter. They have sextiles all in between them, and then Pluto and Jupiter have this opposition. This will be active all summer, and in general, this is a favorable configuration for greater activity. When you have the planets in geometric relationships to each other, that seems to alter the morphic field of energy or the ether or something. We really don't 100% know. We know there's electromagnetic waves implicated with this, how they affect the sun, the gravitational dynamics and more. But when you have these geometric relationships in these long-term configurations, because these planets move slowly, you get more activity. Another big day to watch coming up is August 1st. We have a very nice planetary geometry set up then. I did post on that on my X account. I'll link that in the video description as well. But in addition to that, for the 1st of June, here's the Earth. We see it's in opposition to Uranus and Ceres, almost perfect, but not exact, but still with this opposition. Then it has this square there to Mercury and Venus, and they are also square to Uranus and Ceres. So Mercury is seen as the activator of heliocentric planetary geometry. It's swinging in, it's activating Venus there, and also triggering this square to both Uranus and the Earth. So Earth is part of this critical planetary geometry. And not only is it part of this square and opposition configuration, it's also then taking part in this basket configuration because it has this trine over not only to Saturn and Neptune, but also to Mars and Eris. So it's participating in all of that. So it looks like, well, at least we have the background configuration set up for there to be some significant solar activity and or space weather right around this time frame when we have this sunspot here going to be in that strike zone. We don't know how it's going to evolve or grow or flare or anything through that period of time, but that's making it look more likely. So that's the short-term forecast. All this solar activity, let's say we get it, and I think we will, we'll charge up the ionosphere, the global electric circuit, all this, and then as we continue down into the descending phase and towards solar minimum, which will be like 2029, 2030, 2031, right? It's going to take some time, but as we continue to move towards that, we probably will have more and more earthquake activity. That's what our research and our data sets indicate. Though, of course, these are short-term data sets in terms of the geologic history of the Earth, right? But that's what the best data indicates. And so let's look at some of the recent earthquake trends to get a sense of where we could potentially have some big earthquake activity in the near term and also over the long term going forward for the next few years. Here we have our global earthquake map for all earthquakes magnitude 6.5 or greater going from January 1st of 2024 up to now. You see tons of activity here in the Western Pacific. You see that we had a magnitude 8.8 megaquake, biggest since 2011. It's been a very active solar maximum, surprisingly so. And the fact that it has been so active is kind of indicating to me that this solar minimum may be very, very active. So, and you see that the second strongest earthquake during this time frame is an aftershock for that magnitude 8.8 megaquake. But of course, there were many others. 7.7 in Burma. You have the 7.6 Japan. We also have 7.5 Japan, though here on USGS it shows up as 7.4. So there's been a lot of activity, but you'll notice a few spots that aren't filled in. Because if the Pacific plate is moving, which is the biggest plate as I mentioned, and you're getting all these earthquakes to rupture and it's moving around, right? Well, the entire plate to some degree needs to move, or else there's going to be flexing stress applied to parts of the plate. Because if it's moving here significantly 5 meters from a big slip, let's say the magnitude 8.8, can be like a 5-meter slip, let's say. Well, how is it accommodating motion over here in California? So if you look, we just had this magnitude 6.9 there in Chile. If you click here, you see that we had a 7.4 in 2024. So this is why adding 2024 into this is very key. You see a 7.2 there in 2024. So we have pretty good coverage for earthquake activity for the northern part of South America since 2024. Notice this huge gap down here where we don't have anything. And that's a big, very powerful subduction zone, and these earthquakes are not rupturing the entire length of that. If we go further down, we see our antipodal quake activity that we have for the megaquake. Here in Drake Passage, 7.4, this should be a 7.6, a 6.5. So there's been slip and movement there. If you go north, we see this activity here in Mexico this year, the 2nd of January. Interesting to note about that is right now, at this moment in time, we are seeing this new hydrothermal mud pit popping up in someone's backyard here just to the north. So if you zoom in, I can show you the rough location of it. It's right around here. And one of these houses here is now having this like mud volcano explode basically in their backyard. So this area has a whole bunch of old volcanoes and stuff. If you zoom around, you'll see them, cones and everything. So we're getting active movement of the plate here. And this is, the Pacific plate and also the Cocos plate. And you have this mid-ocean ridge there. This used to all be the Farallon plate going up. But we are having movement here. We are seeing this bubbling of activity. We zoom over to Papua New Guinea, for example, you'll notice all these earthquakes here, none of them are magnitude 7. We have some 6.9s, but no magnitude 7s. We are having this, this big ridge volcanic eruption here in Papua New Guinea, right along one of these boundaries. So there is this release of energy that way, but this is one area that hasn't had as much slip as you may think, because there haven't been these magnitude 7s, and the way earthquake energy scales is really quite significant. But there have been earthquakes there since 2024 to accommodate some of this motion. But you go to the south, you see New Zealand has this 6.7 right there, but you have a whole large section there, including basically most of New Zealand, especially the Alpine Fault, that hasn't had any big ruptures. So that's a zone to watch as it relates to big earthquake activity, balancing out the movement of the Pacific Plate. We have the 7.3 here, Alaska. That was last year, right before the megaquake in Kamchatka. But in general, we have a lack of movement along the Aleutian Island subduction zone. We have this Hubbard Glacier earthquake here, magnitude 7. That's right there along the plate boundary. When that first happened, basically people in the USGS were saying it's not related to the plate boundary, whatever. Well, if you read the tectonic summary now, basically it's saying that it's right along the Fairweather Fault, which is a major plate boundary fault in the region. And it has the fault plane characteristics, like the moment tensor plot indicates that it's very much, accommodating that plate motion. So you got to sometimes go back to these things to see what the truth is rather than what some of these officials may say at the time of. But we go here, we see a 6.5 there in 2024. This is the 15th of September, right at the top, the triple junction of the Juan de Fuca plate to the north. And then we see this magnitude 7 there that struck on the 5th of December 2024 at the bottom of the Juan de Fuca plate there at the triple junction. But you'll notice nothing for California or Baja and the San Andreas Fault. So we are definitely, we have not accommodated that plate motion that's occurring for the Pacific Plate as a whole, at least for this time frame of 2024 up to now. And I would say also Mexico, even though we have the 6.5, that's also probably not sufficient too. You can get big magnitude 8 quakes there, and actually that happened in 2017. But there are plenty of locations that are overdue for big activity, and at some point you'll get it shifting from the Western Pacific to the Eastern Pacific. Okay? We've had tons of activity around Japan, tons of activity with Kamchatka, tons of activity in Indonesia. If we zoom in here, you'll see these big magnitude 7 earthquakes that occurred, some of them very, very deep. Check this one out, 640 kilometers down. That was in 2024. We had another one that was very similar nearby, also 630 kilometers down. So that's the one that occurred this year, 2026. Here's the one that occurred in 2024. So there's been big motion and movement accommodated along the Pacific and also some of these adjoining plates. This is the Philippine Sea Plate just in the past 2.5 years, but other areas are very, very deficient. So that is very important to know, especially if you live in one of these regions. If we look at our seismic activity, here we have it for 2026. And you notice that we are starting to have a bit more seismic activity in general than we did before. And this 7.5 there, Japan, right? That's the 20th of April, that being a one-off. And then effectively we had low moderate activity until you go back to this seismic burst that occurred in March and April of this year. But now we've been seeing more activity over the past week or so. And I think that's likely to continue. And then as we get to mid-June, we'll have that coronal hole rotate back. Right now, it's about on the opposite side of the Earth exactly. So we're about 2 weeks away from another coronal hole rotation that's likely to drive a high magnitude earthquake, magnitude 6.5 or greater, and actually most likely a magnitude 7. We could even get a burst from that coronal hole rotation. But if we go to 2025 and look at our activity, we see something interesting here. So here is the beginning of 2025, and you see these dark burgundy bars. These are for the strongest earthquakes, magnitude 7.6 or greater. This is Cayman Islands in the Caribbean. This is the quake that struck Burma. You see that we ramped up to this 8.8. This one should be, it's off the scale because this only goes to 8.2 as you can see. So this is off the scale. Look at how we then ramped down. We had this big global burst of seismicity, and then when we did get big follow-up earthquakes, they were all lesser magnitude than the last one. So that's the regime that we've been in right now. And if we take this recent data here and go forward with it, we see that it's the same deal here. So then we go forward and yeah, we've had these magnitude 7s, but we haven't had any that have broken that magnitude 7.6 barrier and really been these big earthquakes like 7.8, magnitude 8, right? We typically get one magnitude 8 every single year. We had one last year and then we have 4 years without a magnitude 8. So in terms of that scale and reckoning, we are still overdue for more megaquakes, magnitude 8 or greater. And solar activity all the while is going down. So we can check that out by going to our solar cycle progression chart here. And I'll zoom this back to solar cycle 23. We can turn off these percentile zones. And here is solar cycle 23, this is solar cycle 24, this is solar cycle 25. So this is the bottom of a Gleissberg cycle right here, this like roughly 100-year-long variation in solar activity. There's some variance to it. One of the leading ideas as to what generates the Gleissberg cycle is that it's the shared orbital resonance of Uranus and Neptune. Uranus having an 84-year orbit, Neptune 164 years. So the combined, they create that roughly 100-year orbital resonance. There's a lot of research into that. It's very, very interesting, showing the connection between planetary geometry and, well, solar activity like we have coming up very, very soon on the 1st of June, as I showed you earlier in the video. So solar cycle 25 has been stronger than 24, but 24 was anomalously weak, and solar cycle 25 hasn't been exceptional. The average sunspot count is 175 for solar maximum. You see that we had 1 month at 215. This is August of 24, but in general, we hover at this 150 range. So we are still near the bottom of this Gleissberg cycle. If we go the full scale here, you see the Dalton minimum there, 1800. That's the bottom of a Gleissberg cycle. You see how it goes up. We went back down here. This is the Gleissberg minimum at the early 1900 zone. Then we ramped up and now we're here. So we're still roughly in that trough for solar activity, though we are going to start ramping up. So we're definitely still in this zone where we can have big earthquakes, or at least you could say we're statistically more likely to have big earthquakes. And as we go towards solar minimum, that wavelength is going to constructively add to this Gleissberg wavelength, and we could get some really big shakers. So that's why it's important to track the movements, because at least as it relates to the Ring of Fire, there are certain key locations, southern part of South America, roughly Baja and California. I would even still say this whole area there with like British Columbia, Vancouver Island. That's only a 6.5, I think it was. Yeah, 6.5. It's only 6.5. That whole area, a lot of the Aleutian Islands, Papua New Guinea, New Zealand, and north of New Zealand, they are all still basically waiting to have their big equivalent movement as the other parts of the Pacific Plate or nearby zones, Philippines, Indonesia, Japan, Russia, Kamchatka, etc. Now, there are, of course, other plate boundaries that exist. We have Europe here. We had the biggest earthquake in 10 years in Italy recently. I was there for that. Didn't feel a thing because it was super deep, 375 kilometers down. That was a magnitude 6. And then you have, of course, big earthquakes that can occur near Greece, Turkey. If we were to zoom out, we would see the magnitude 7.8 and 7.5 earthquakes that struck Turkey in 2023. So that's not in this data set. So you do have some big earthquakes that have struck recently, but as it relates to the past 2.5 years, not too much movement around Africa, Europe, etc. So that's always possible, but in terms of forecasting activity, we really see clear zones where we haven't had movement in quite some time. And as you do have more and more movement here, right, that's only going to apply more and more pressure to these locations as the plate is going to have to flex more to accommodate them still being stuck. That strain accumulates, and then you get these trigger mechanisms through the sun or through planetary geometry that may not be, of course, the only progenitor of an earthquake, because it is, plate tectonics and strain accumulation, but they certainly can act as a trigger to cause something to finally rupture or to influence the energy loading to be faster, like these big coronal holes that have been rotating continuously on the sun. So I wanted to give you that update, give you kind of a bird's eye view of where we are as we go forward in 2026 into solar minimum a few years from now. Of course, I'll keep you up to date as to everything that's happening with solar activity. The biggest thing coming up is the fact that we have this big sunspot right there rotating towards Earth's center. We have these other ones also making that journey. They could go active at any time because all these sunspots here have shown activity in the past 2 weeks, but on Earth facing they haven't. And I think it's most likely that we get some Earth facing activity around the 1st of June because we have this very key planetary geometry that's active at this time. Again, this is a true sky, constellation-based, heliocentric chart, and that is what you use for forecasting solar activity based on planetary geometry. So that is your update for today. Thank you all so much for watching, everybody. I've been your host, Stefan Burns, geologist, geophysicist, your space weather guy, and cosmic bro, here to help you understand what is happening on the planet. I release videos almost daily. So if you'd like to stay up to date with everything, then please subscribe and smash that thumbs up button to help the channel grow. Thank you all so much for watching. Wishing each and every single one of you well. Please take care of yourselves, and I'll see you all in the next video.